Hey guys, welcome to today's workshop where we'll be looking at scaling our ComfyUI. The goal for today will be to 10x our output. So by the end of it, we'll be using 10 GPUs at the same time, and these GPUs will be in different places. So that should be pretty interesting, pretty exciting, I think. So we'll be basically setting up a distributed network. So what that is basically ComfyUI instances running on separate GPUs but working together and being controlled by a master. And the separate instances running on separate GPUs, I refer to them as workers. And we have three types of workers. So we have the cloud worker, the remote worker, and the local worker. So a local worker is a GPU inside of your computer. So if you have, for example, two GPUs inside of your box, the first GPU is going to be the master. The second GPU will be the local worker. The next one is remote workers. So remote workers are basically GPUs in a different computer inside of your network, your local network, or even in a different network. So for example, if you're working from home, your home office, and then you have a few computers over at the studio or something, those can become remote workers as well, where you can control them from your home office and utilize them. And the third type is the cloud worker. So that's a GPU running in a cloud service like Runpod that we can rent and utilize within our local ComfyUI instance. To set this up, we'll be using a tool called Distributed. So this is a tool I launched about a month ago with a great reception. And so one of its strengths is ease of use. It's because once you set up the workers, that's it. You only set them up once. Apart from cloud workers, because they're temporary. So, but that's a bit different. But for local and remote workers, we just need to set them up once. And then converting workflow is very easy. We basically need 2 or 3 nodes, usually 2, to convert any workflow, basically. So nice and easy. And then monitor workers. So we're able to check the health of our workers. We're able to check our logs. We see if they're running, if they're offline, and so on. And then, this extension also allows for creative upscaling. So meaning it speeds it up by quite a bit. So we'll be looking at that as well. And then finally, it allows for cloud GPU support. The plan for this workshop is going to be, first we'll have a look at quick demo. So we'll have a look at how it works. So you kind of get a big picture idea of what we're working with. And then we'll go through the setup of the local and remote workers. Then we'll convert a random workflow. So I'll show you can basically just find, like any workflow you can just easily convert to a distributed one. And we'll look at the distributed creative upscaling. We'll compare the speeds to the original Ultimate SD upscaler. And then we'll look at setting up cloud workers and setting up multi-GPU pod, which is pretty cool. And like I said, by the end of this, we'll have 10 GPUs working together within our local ComfyUI instance. Cool. But before we go any further, let's just quickly run through the limitations, because this is something that comes up and people ask about. So one of the things that a lot of people ask first is whether it will speed up the generation of a single image or video, and currently not. And sadly, there isn't any other solution out there that does in ComfyUI. There are some early projects that are attempting it, so hopefully soon. But right now, the best way to utilize multiple GPUs is to generate more at the same time. This works best with similar GPUs. So if you have a situation like this, it's not going to work very well. So the GeForce 256 from 1999 is just going to slow down the RTX 5090. It's going to create a bottleneck, basically. So yeah, you want them to have similar amount of VRAM and processing power. So currently it doesn't work with the desktop app. So we're going to need either the ComfyUI portable version or the virtual environment version. Cool. So that's it for limitations. Let's jump into ComfyUI. I'm actually going to delete this file here. So that's the config for the GPUs, so that I start fresh. Basically, now if I refresh the page, it's going to be like I just installed the extension. But before I do that, I will show you how to install this extension. So, and it's pretty straightforward. You can just install it through the Nodes Manager, and if you just type in distributed, it will come up, and yeah, pretty easy installation, and it doesn't require any like dependencies, so you're not gonna have any dependency problems with this. So that's good. So now let's refresh the page. So this is like as if I were to launch it for the first time. And then here you can see in the upper right corner, hopefully, it's actually being blocked by my camera, but up there was a little notification saying that that it detected my GPUs. So here you can see that I have 4 GPUs. The master is one of them, and then the 3 workers. So that was automatically detected and configured for me, so I don't need to worry. So that's pretty easy for local workers. Let's have a look through the UI. So you can toggle down each of the workers in the master for more options. For master, generally you don't need to change much, but sometimes you will need to change the host if you're using Cloudflare tunnels when working with cloud workers, and I will show you guys how that all works later. For the workers, you do have the launch arguments, so extra args. Here you can add things like, in my case, I'm going to add Sage attention, so that things work a little bit faster for us here. So we can save that, and then we can basically just launch the workers. And down here we have 2 buttons. So these will basically clear the VRAM and interrupt the workers when you're running a workflow. And just note that these buttons work for the workers only, but for the master, you have to use the buttons, down here and down here. With the workers, local workers, we can have a look at the logs. So we can see what's going on at all times. For each of the workers, we can see what's happening, which is handy. And yeah, so now next thing we'll have a look at a little bit of a demo of how it all works. So now we have our workers ready. So you can see the green dot here. So we can run the workflow. So here, I'm just going to bypass this node, which is one of the custom nodes required for this to work. And I'll run the workflow. And we just get a single image, right? As expected. But so actually, I'll just note now that we'll be using 1.5 models for the purpose of speed. So we don't need to wait for generations too long. But obviously, this is going to work with any model. It's going to work with Flux. It's going to work with video models, which we'll look at soon. It's going to work with Qwen, any models. Okay, so now if we activate this node and we run the workflow again, we get 4 generations. And run that again, and we get 4 generations. So there we go. We have 4 GPUs working together to generate 1 image each. Cool. Now let's have a look at upscaling. So before we have a look at the distributed upscaler, let's have a look at the standard upscaler so we can compare the speed. So I'll just let this run. And in the meantime, while that's loading, which will take a second, let's have a look at the options for the distributed upscaler. So it's basically the same options as the ultimate upscaler. It's just missing the seam fix. Yeah, because I don't know. I find that generally I never use it, and I found that people also don't use it because it's a bit hit and miss. So I haven't implemented it, but yeah, I do have other options. So I have a static distribution. So now I'm going to show you guys a quick demo of the difference between static distribution on and static distribution off.
Instead of pre-assigning tiles to each GPU, the system now uses a queue where faster GPUs automatically process more images, ensuring your powerful cards aren't waiting for slower companions.
This is great for people that have asymmetrical GPU setups, meaning some GPUs are faster than others. So you can see here, it took 45 seconds for that. Okay, so now let's run it again to see what time we get with the distributed one, and the settings here are exactly the same. So we get 12 seconds. So before we had 45 seconds, now we have 12 seconds, and the settings are exactly the same. So quite a big difference there. Okay, that's cool. Now next thing, let's have a look at video. So I'm gonna try doing 4 videos at the same time, but I'm just worried that the card that's running my OBS for recording the screen is just gonna, yeah, it's gonna create a bit of, actually no, I'm gonna do 3 because I'm just afraid that we're gonna run out of VRAM because I'm just doing a 4K recording here. So 3 would be enough. So let's do 1, 2, 3. So we're gonna get 3 videos here. So let me run that. And while that's processing, let me just show you the difference in using a video workflow. For video workflows, apart from adding the distributed collector like we do with just a normal image workflow, we also should add a image batch divider. So what this does is basically divides the batch of images by the number of workers that we have, including the master. So basically I'm using 3 GPUs here, so I should divide by 3. And that will give me 3 videos. Because if you don't add this, it's just going to create one video that's got kind of 3 videos in it. So kind of like a montage, I guess, which is something that you might want actually. But if you want them to be 3 separate videos, then you should use the image batch divider node to split them into 3. While that's processing, let's have a look at the requirements for distributed, which I have here on the GitHub. So there's really 2 requirements. One of them is that we, as discussed earlier in the limitations, we need to be using the portable or the virtual environment version of ComfyUI. The second one is we need NVIDIA GPUs. Currently no AMD or Intel support, which might change in the future. We'll see how we go. Anyway, so here is our 3 videos. It's cool. So that's a video distributed workflow done. We looked at the requirements. Now we'll look at the setup. Let's have a look at the setup. So we already kind of seen the automatic setup of local workers, but I'm just gonna show you guys something important when it comes to setting up distributed. So here is like a standard bat file for launching ComfyUI, where you add your extra arguments. And when you're launching the master, it's essential that you add this, and this is on the GitHub. So any commands or links I'm going to be using here, it's all on the GitHub. You can find it there in the guide. But yes, you need this because this allows HTTP communication between the master and worker. So without this, it's just not going to work. Cool. So yeah, so I've already have it launched with that, so that's done. Let's have a look at setting up local workers. So like I mentioned before, it was automatic, But if you do need to add a local worker, because for example, let's say you've added a new card into your box, and yeah, that's added as a new worker. So here we have the add new worker button, and here you can choose the type of worker. So we choose local, and here we just need to make sure the port is different from the other workers we have. And the CUDA device, we need to find the CUDA device for the new card. We can use that. We can find that by typing in NVIDIA SMI into the command prompt, and this will give us a list of GPUs we have. So obviously I don't have a fifth card, but if I did, it would be number 4. So then I would set this to be number 4 here and save. And while we're here, let's have a look at the settings for distributed. So there's 3 settings, and one of them is debug mode. And debug mode is essential if you have some problems and you want me to help via a GitHub issue, if you open one, or you try to kind of troubleshoot yourself. This will give you a lot of information both in the terminal here and in the browser console as well. So, and on Firefox, I just pressed Control Shift I to get to here, and this will give you a lot of like debugging stuff that you can use to find the issue. And the second option here is auto launch local workers on startup. So when you launch the master, it will automatically launch all the workers here you have selected, ticked, which is handy. And the final one is stop local workers on master exit. So if you shut down the master by closing the terminal, or yeah, basically usually that way, it will shut down the local workers as well, so that you don't have like orphaned processes running in the background. Cool, so that's that. So now let's have a look at setting up remote workers. First, I'll say that when you launch, basically on a remote computer, you also have to have the distributed extension installed, and the models and the extensions you want to use in the workflow. So you have to kind of replicate what you have on the master on the remote workers. But when you launch the remote worker, you have to also add listen to the arguments, and this will allow ComfyUI to bind to a port that you open, which we'll be looking at in a second as well. So here I have the remote worker, and it automatically, because I have 2 GPUs on the remote worker, so automatically detected my second card as a worker, and that's all running. The only thing I'll add as well is that if you do have multiple GPUs in the remote workers, you need to add listen to each of them as well. So that's good. That's all running for me here. And so now let me go back to my master here, and I'm going to add those remote workers. Actually, one thing I forgot to mention is that, yeah, like in a local network, you should open the ports for the remote workers. So you can do that on Windows, in the Windows Defender firewall. You go and create a new role for the port, and then you set the 8188 and 8189 ports, 8188, 8189, and then you allow the connection, and you should do only private network, and then you can give it a name, and then that will basically open those 2 ports. I'll just mention that if your remote worker is on a different network, not on a local network, I don't recommend opening the ports to the internet. Instead, I would recommend doing Cloudflare tunnels, and we'll be looking at Cloudflare tunnels in a second. Okay, now that we have the remote workers configured, let's add them on our main instance. So we'll go to remote, which is remote, and we'll use the local IP address of that computer, and the port will be 8188 in that case. So it changed green, so we know it's connected. And then we add the second one, and it was 8189. We save, and boom, it goes green. We know it's working. So now we have 6 GPUs working together. Let's test that out. So we'll run this workflow, and we'll get 6 images. So we're more than halfway there to 10. We got our remote workers working. That's great. So now let's quickly have a look at converting any workflow to a distributed one. So I'm just going to go into the templates, and I'm just going to have a look at a random workflow here. So let's go with this one, for example. And I'm just going to change this to a model I have here. So yeah, that one. And just a random image. That one is fine. And this is an in-painting template. So let me just add a mask here. I'll just do the face and teacup. The prompt at the moment is teacup on a pink tablecloth. Let's do a man's face. And what's the denoise at? It's pretty high. Let's do 0.6. Cool. That's done. Okay. So now for this workflow, we only need 2 nodes. We're going to need the distributed seed, which will basically give us a different seed on each worker. Which is, but it is predictable. So, so this seed here is going to be what the master is using, but each worker will basically have +1 of that seed. Will be an iteration of +1 for each worker. So you can basically worker 1 will be this seed +1, and then worker 2 will be this seed +2, and so on. And then after this, we just need to add the collector. Yeah, that's there. And yeah, so that's pretty much ready to go. We can run this. So we should get 6 versions here. Well, scary. Cool. So we got 6 options there. And note that the image here that we have on our master, it got sent to the remote workers. So that's no issue there. So that's good. That works. And for video, the difference is going to be just that for a video workflow, we just need to add the image batch divider, and so we can divide them into separate videos. So yeah, that's that. So now we've got 6 GPUs running. So we need another 4 to get to our goal today for 10. So how are we going to do that? We're going to be using Runpod. So Runpod is a service where you can rent GPUs. And here I have a whole guide on how to do it. So we'll be kind of following that more or less. So one thing I would say that generally I recommend getting storage for your models, which you basically kind of rent per day for like a small amount of money, and you can keep your models there so that like when you shut down a pod, basically it deletes everything. But if you got network storage, it will keep the stuff you have on there so you can access when you rent another GPU. Yeah, and for this tutorial, we'll be using the ComfyUI distributed pod, which we have basically a pod template ready for us to use. We've distributed, and it has all the stuff you're going to need basically, apart from the models. So you're just going to have to download the models there, which I'll show you. So to get to the pod template, you can just go to the GitHub and into the guide, and then click on this link here, and this will take you straight to the pod. And then you're just going to have to, because we'll be using 5090 today. So for 5090, you just need to make sure you choose CUDA 12.8 in the additional filters. And then if you're using the network storage, you can attach it here. For me, I'm not going to do that because I'm going to show you guys how to download the model. So we're going to rent a 5090. and we jump into the template settings, into the variables here. So here you have to grab your Civit AI token, which I have saved here, and Hugging Face token. So these two tokens are essential if you're going to be downloading models for the first time. But later on, if you already have all the models downloaded onto your network drive, you won't need that anymore. And then if you want to use Sage Attention, you just set this to true. But in my case, I will set that to false because it's just I don't need it right now. And so we're going to do 4 5090s so we can reach our goal of 10. And we're going to deploy. Cool. So now let's have a look at downloading models. So here I have kind of like a bit of a guide on how to do that. So we'll be looking at how that works. So let's say we'll be doing this workflow that we want to distribute. We'll go into this little icon here and we'll go to Files, Export API, and we'll save that to our computer. And then we want to go to an LLM that basically supports browsing the web, for example, Grok. And we'll grab the prompt here, paste it in, and bring in our API workflow. And now run it. And basically Grok will go through the workflow, find all the models and find links to them online and create a script for us that we can then run on Runpod to download the models automatically for us into the right folders that match our local ComfyUI. So we don't need to worry about putting in the right folders and stuff like that. While that's processing, we'll do one more thing. So as mentioned before, we need to create a Cloudflare tunnel and download the Cloudflare client from their GitHub. If you Google Cloudflare and go to releases here, and you can find an install for your operating system. In my case, it will be this one for Windows, and I installed it here. Actually, it's not an install; it's just a portable app. So you can just create like a bat file, for example. So this is a bat file I've created, and that just runs the Cloudflare tunnel with this argument here. So this port is basically the port I'm using the master on, and you don't need to open this port to the web or anything. So this Cloudflare will basically create a secure connection without you having to open any ports to the internet, which is nice. So I can just double click the Cloudflare tunnel bat, and this will create a address for me for my master. And then if I jump into my main instance and replace the host with this address, now my Cloudflare is ready and set up, ready to go to work with Runpod. Let's have a look at Runpod if it's ready. Yeah, it looks like it's ready. So first we'll have a look at downloading the models onto here. So if we have a look at Grok, we can copy the output from Grok, come into a new document here, paste it in, and we have the command here to download that model into the right directory, and we can save it as download_models.sh, for example. I'll just save that. And then if I jump into Jupyter Labs, I'll go into workspace folder, and here I'll drag and drop that file. And back to the guide, I can grab these two commands, and this will basically so here I just open the terminal and I'll paste these commands in and just confirm the name, and this will download the model for me into the right folder, and it will be ready to go in a second. Perfect. So now let me open the main instance of the Cloud Worker. I just want to show you guys that you can, I just want to show you guys first with the Cloud Worker. So now this is the Cloud Worker here. that you can basically run everything within just the cloud worker. So you can use 4 GPUs at the same time without even using your local ComfyUI if you don't want to. And it's quite convenient, so it's automatically kind of set up for you. So it automatically detected all the GPUs. So you can see you've got the 4 GPUs here, the master and the 3 workers. And we can just launch the 3. And then we can just bring in that workflow that we processed through Grok to get the model. So that model will be here. And then that's ready, so we can run the workflow. And there you go. You got 4 images. So I'm having a little bit latency here because I'm in Australia and this pod is in America probably. So there's a bit of a delay here, but it works okay. That's basically running a multi-GPU pod, all within Runpod, and yeah. And this will work with video or images, anything. So now let's have a look at adding these 4 workers into our local ComfyUI. So if we go back here and we can just copy the link here and jump into our main instance here and set the worker type to cloud, and we paste the address here. We can copy that as well, and then if it turns green, that's good. So that's 1, and we go cloud, and we just change the port, so increment the port by 1, so that's 89, and cloud, so here that's going to be 90, and then 1 more, and that's going to be 91. Cool. So now we have 10 GPUs basically ready to go, and we're going to run this workflow, and that should give us 10 images. Yep, there you go, 10 images. So we got there. We got 10 GPUs working together within ComfyUI. So this could be 10 videos, could be 10 Flux images, 10 Qwen images, whatever. You can even increase the batch size to 2, which will give you then 20 images. As you can see here, we can even do 4, which will really take it overboard. You can see those processing. So the 59 is finished pretty quick, but the other car is a bit slower, but you can see that you get 40 images very quickly. Yeah, so that's that. So let's go back to the presentation here, and let's have a look at what's next for ComfyUI distributed. So apart from obviously like being able to speed up the generation of 1 image or video, which when it's possible, that's something that I'm going to be keen to implement. But right now what I'm working on and focused on is video upscaling, video creative upscaling, using Qwen 2.2. So that's almost working, and that's going to be very good. It's going to be way faster than doing it with just 1 card, that's for sure. So I look forward to releasing that. The next thing is branching. So branching is an idea from one of one of the users of distributed, and it's basically where one workflow can be split into different branches. Like one GPU is gonna take care of one part of the branch, and the second is gonna do something else, and the third is gonna do something else. But then they're gonna converge together later on in the workflow to create one output. So, for example, one GPU could be doing pre-processing, the second GPU could be doing, like an initial sampling, and the third could be doing, some other task, and then the 3 outputs kind of are combined together to create something else, and for the final output. And the third one is master as coordinator. So this is basically where, if we come in here you can see the master is grayed out. We can't untick it, but we can untick the other one. So that means that they're not going to run when we run a workflow. But the idea is that we can untick the master. And that means that basically the workers do all the work and the master is just coordinating. So it's sending out jobs and receiving results, but it's not doing any processing, which can be good if you're, for example, working on a laptop and you don't have the compute power and you want, remote or cloud workers to do all the heavy lifting. And then the fourth one is basically, here you can see you have logs for the local workers, but you also, the idea is to have logs for the remote and cloud workers, so you can see what's going on with them at all times. So that's going to be something that we'll add in the future. And yeah, so that's it. So that's pretty much the workshop for today. We managed to get 10 GPUs running together at the same time, and we set up local, remote, and cloud workers together. So if you want to find me on YouTube, X, or GitHub, there'll be a lot more information there. On YouTube there are more tutorials, so if you missed anything, and on GitHub there's a lot more details there, links and commands and stuff that you might need. So find me on there. And so thank you very much for your time today, and I'll see you guys out there. See ya.